Hello everyone, welcome to watch ZW3D training video. In last video we have introduced about the drilling workflow and also how to define the whole feature. And in this small video we will introduce about drilling operations. So we will introduce the key parameters, and also we will show you the operations for drilling one by one. Okay, now let's continue. Here I would like to introduce about the key parameters for the drilling first. So as you can see from here, these are the common settings for all the drill operations. So the first we can set the cut order. As you can see from here, there are a lot of cut order selection, and also you can preview the result. And then it's about return type G99 and G98. So this is the G98 and G99. And the return distance, so we can define the return distance, and the drill will start from that plane to do the drill and the rapid return to this plane. And the dwell time is to define the times to stop in the bottom surface. The unit is the second. And also the access type and the safe distance defined in the access and link. We can define the access type as 3 access or 5 access, and define the safe distance to cross the island, as you can see from here. Let's just check inside the software. In this model, we already defined the whole features here, and also we define frame for the hole in the front view. Okay, so let's check the drill. We add the part and also this whole feature, and we define the hole. The first hole, the first tool. Then let's check the parameters. So here we will introduce about the common settings like cut order, return type, return distance, and dwell time. So the cut order, as you can see from here, we can set the pick order if we define the whole feature by pick order, and minimum distance or x zigzag, x one way, and so on. For example, x one way, we can calculate the result. This is x one way, and also min. And we can define return type. This is the initial level. So when we finish one hole manufacturing, then we will go link to another hole. So we will return to the initial plane first. So if we define the R level, G99, so we can find the differences. And also we can define this return distance like 5. So you can check the result. Here the -10. And also you can find that start drilling, and after that it will return to this R plane and then to another hole. Okay, and also we can define 3. And the dwell time is to define how long you stopped at the bottom surface, so it can make the bottom surface more smooth. And also another 2 common settings is the access type and safe distance. Let's check the safe distance first. For example, I can set 5 to check the difference. So you can find that here we go down to the R level, R plane, and then drilling, and go back to the R plane, and then go to this safe distance plane and link to the next hole. We can just keep the default setting. It's okay. Calculate and okay. We can hide this and duplicate one, and we can remove this and add this, the hole in the front view, and we need to define another smaller drilling like 5, and drill D5, the second one. So we can just calculate. You may find that there's an error. It cannot create the CAM2 path. So this is because we do not define the frame. So if we use the front frame, and we can calculate correctly, right? And we can also leave it none, and we can set here 5 axis. So it can also calculate the 2 paths correctly. Next, we would like to explain you about the drill operation. So actually we may need to spot drill for some holes, right? There are 2 ways to do the spot drill. We can use the center operation, just set the max cut depth to a small value like this, and it is more used to drill center hole. And also we can use the drill. We can leave the max cut depth empty or set a small value for the hard material, and we need to set depth reference as spot drill. Okay. And for the other common parameters like the max cut depth, we usually leave it empty because it will read the depth from the hole feature. For the through hole, we may need to set it through depth to make sure the hole has been drilled completely. Okay, and also the depth reference, we can set it as it is necessary. So let's just check inside the software. Let's continue. We just created a drill for these features, these holes. So let's check more information. Here we can set the max cut depth, and also we can select the depth reference. So first we may need to use the spot drill to do the spot drill. So we can just calculate. So you can find this is to do the spot drill, and we can also set the max cut depth to a small value for the hard material. Okay, and we can also use the center operation to do the spot drill. For example, this one, and we can define, select a center drill. We just leave it by default, and we can just set this value, then check the result. Of course, you can find that this we need to add the part, then recalculate. You can find the result. So we can just delete this. Okay, let's continue. Then we can duplicate, and we can do the drilling. So here we can leave it empty and through depth 1. Okay, let's calculate. So you can find this result, but actually we need to select the correct depth reference. For example, if we select tip, So we can just verify to check. You may find that this hole is not drilling completely, right? So we need to set the shrunk and calculate and then verify. Yeah, this is what we need, right? So this is about drilling. So we just introduced about drill, but for some deep hole, actually we need to consider about the cooling and chipping. So we may need to use the pack or chip operations. So let's check the differences between the pack and chip. As you can see from here, this is a pack. So every time when we drill a dip, then we will go back to the R plane, then next, and then go back to the R plane. But for the chip, we drill at depth and then recheck at distance, and then we go down to another depth and then go back to a distance. So as you can see, the setting is defined in the operation like pack setting and chip setting. So the max pack depth, minimum pack depth, and recheck offset, reduction start, and also reduction factor. So you can see the detail move. Okay, so let's just go to check inside the software. In our model, there are two deep hole. This one is diameter is 5 and depth is 15. So the depth and diameter ratio is 3, and also another one is 6. So how can we drill this kind of deep hole? Actually, we can use pack and chip. The pack is for more deeper hole and chips for deep hole. So let's check pack first. For example, for this, we can select this deepest hole and also part. That's okay. And we can, this hole diameter is 5, so we can define the G05, D5, and so let's check these parameters. So here it's okay, and 5, 3, 1, this start from 2, so the same as it in the slide. So then we can calculate and check the verify. First, go to the 3, and then G to minus 5, and then go back to the R plane. Then go to the minus 4, which is offset 1 millimeter to the minus 5, right? And the next minus 9, which is minus 5 plus 4, okay? This is about the pack. And let's check the chip. The same, we select this hole. So the same, D5, and then we define the same. Start from second and calculate and verify. So first 3 and then minus 5 the same. But when we recheck the tool, we will go to the minus 4. We will not go to the R plane. Okay? And minus 9 and minus 8. Okay? Let's learn about the rim, ball, fine ball. Actually, these 3 operations are for the precision hole drilling. So rim is for small hole and ball is for big hole. we need to drill before rim or ball. So let's see the differences. The rim, the spindle keeps working at the bottom surface and retract at feed speed, and the ball spindle stops at the bottom and retract rapidly. And what's the difference between the ball and the fly ball? Actually, as you can see from these two images, ball is a line to pass, but for the fly ball, when we drill to the bottom surface, we will offset a distance, retract rapidly. Okay, the setting can be set in here in the path setting, the orange angle and off-center distance. So let's just check inside the software. Okay, let's continue to learn about the rim, ball, and the fly ball. So all these three operations are for the precision hole request. Okay, so what's the difference between rim and ball, and also what's the difference between ball and fly ball? So let's just check out. So the first, the rim is for the small hole, and fly ball is for the big hole. So for example, if we want to drill a precision hole here for this hole feature, so first we may need to modify this drill. We may add a new smaller drill. So, okay. Then we can recalculate. After that, we can use the rim. We select this and this one will feature and define the tool, rimmer. So the diameter is 10, okay? D10. So this is the false tool. So actually calculate, it's okay. We can just verify. So our plane, and then we will use the feed to do the drilling and go back with this field. Okay, and let's check the ball. We have a big hole here, diameter 30, so we may need to use the ball and fly ball. But before we use the ball, we need to do the drilling first. So for example, we can just duplicate this one, and we can remove this hole, add the feature, the big hole as the feature, and change this to a D10, okay, and calculate, it's okay. And we can duplicate another two times, okay. So the first, this we can add to the big one, D20. So this is 5. Calculate, and this one we can just manage to create a new one. And this is 29.5, and this is 6. Calculate. So let's check. Let's check the ball and fly ball. So we can add the ball, the same feature, this one, and define the borrower. like ball. This 25, 27. Calculate. It's okay. And we can add one more 5 ball. So for this hole, and after that we can manage a new one, 5 ball. And this is 25 and 28. Why we cannot create the 2 paths? Actually, we need to check these parameters. Here we leave empty, and here we need to define the boring diameter. It is not 530, right? And also we can change this angle like x-axis. So here, calculate, so we can check the result. Like this one, we can find, and then it will offset a distance, and it will not clash to the side surface. So we need to make sure this point, and then go back. It's okay. So you can see the differences between the rim, the ball, and the 5 ball. And also there are 3 more operations: count ball, count sink, and tap. So according to the name, you can find that count ball and count sink is to machine the count ball hole and count sink hole, and the tap is to machine the threaded hole. So what we need to pay attention is that for the count sink or count ball, you need to make sure you have defined the parameters in the hole feature, like here, the count sink hole, count ball hole. And also for the thread hole, the threaded parameters has been defined here. And also the pitch should be the same as the pitch in the tool, the pitch here. So let's just check out inside the software. For this count ball holes, first we need to do the drill. So we can just select this to duplicate, and we can just change the hole feature, this one, and then we can calculate. After that, we can just add the count ball. So we can choose this one, hole feature, and define this, say D15, and this is 9, and then calculate. It's okay. So let's just verify. It is okay. So after that, we can learn about the count sink. This one, this whole feature, how to do the drilling. So of course, first we need to duplicate and remove, add the feature, this one, and then we can just calculate. After that, we have finished the drilling for the hole, the small hole. Then we can add the count sink and manage count sink. Say is the, I think it's 15. It's okay. So just 10 and okay. Calculate. So we can get this result. Let's just verify. Let's check. This is okay, right? You can find this result is good. Okay. And in the final, we need to machine this threaded hole. So let's just check. Of course, we need to do the thread drilling first. Duplicate and choose remove, define the hole. This one. And then we just change this to a smaller div. This is 11, and then this is 4.5. Calculate. It's okay. And after that, we need to use the tab. And this one, okay, a tab, D5, 5, okay, and this is 11. I think it's okay, but actually for thread tool, we need to pay attention to the pitch. So we can calculate correctly. If you change this pitch to the default one, then you can try to calculate. It cannot create the two paths. So we need to pay attention to this setting. That's all for this video. Thank you for watching.